Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. We've got Naked Science here. We've got Dr. Dave and Dr. Dominic tonight in the studio. So radio astronomer and general scientist extraordinaire, aren't you?
Physicist type.
Physicist, yeah. Yes. Dr. Dave, how lovely that you have a friend who is a radio astronomer. Now, what's the difference, Dr. Dominic, between just a normal astronomer and a radio astronomer?
So traditionally people looked at the universe in optical light using telescopes, using the kind of light that you can see with your own eye.
Right.
But starting about 50 years ago, people started pointing radio antennae at the sky to see if it produced any radio waves. It turned out it did, and actually some very interesting objects produced radio emission. So that actually started in Cambridge here at Lord's Bridge in Barton, and also in Manchester at Jodrell Bank, of course.
Yeah.
And so over the past 50 years, actually a lot of very exciting discoveries in astronomy have been made looking at radio frequencies.
Cosmic. He's cosmic, Dave. Fantastic.
Literally, yes.
Absolutely. And I'll just ask you, first of all, Dr. Dave, is there anything, that's new and exciting in science for you?
Well, sort of on the general astronomy theme, I saw a nice little astronomy story. They found a new ring around Saturn.
Uh-huh.
So there's lots of rings around Saturn, and they're all kind of maybe sort of up to sort of 2 or 3 times its normal radius. In fact, there's one really diffuse one which goes out to about 20 times the Saturn's radius. You can't really see that. But they've found one which is absolutely immense. It goes from about 128 times Saturn's radius out to 207 times its radius. If you looked at this, you can actually see it in the sky. It'd be sort of twice as big as the full moon in the sky.
You see, what makes me wonder is why haven't we noticed it before if it's always been up there? How did it suddenly appear?
Because it's not very bright. It's very, very dim. You can't actually see it with visible light.
Right.
You can't see it with radio astronomy. It doesn't work. But you can see it in the infrared.
Yeah.
So the colours sort of beyond the red in the rainbow is infrared. And if you go a long way down there, everything glows in infrared. You glow in infrared. I glow in infrared.
Yeah.
And even this disk of this ring glows very faintly in the infrared. It's really cold, only at about minus 275 degrees centigrade. But it's still warm enough to glow enough for us to be able to see it. They think it's been made by the moon Phoebe, which is orbiting Saturn, actually in the opposite direction to all the other moons and the other rings. And things hit it and stuff gets blown off it, and you get lots of little particles coming off, and this is making up this ring. And they think it might have solved a weird puzzle which people had about one of the other moons of Saturn called Iapetus, which is it's half black and half white.
Uh-huh.
It's like someone's painted half of it black.
Right.
And what they think's going on is that Phoebe is quite dark, and all this stuff is being knocked off Phoebe all the time.
Yeah.
It's forming this kind of big diffuse ring, which is really, really thin, but there's enough of it there and it sort of gets blown around by the solar wind, and some of it comes in and hits Iapetus. And because they're orbiting in opposite directions and Iapetus isn't spinning, all this black stuff just kind of plasters it on one side, whereas the other side is left white. So half of it's black and half of it's white.
Right, let's go to our questions now. Now then, hello to Barry in Stoneham. He says, on my boat, the battery's flat. Feeling a bit down tonight. Loving your show. This is the first time I've tuned in. And Dominica says, if you stuck your head in the middle of nowhere and you don't have any phone signal, is there a way to get it?
It's an interesting question, that one. I guess most of the answers are fairly obvious. Mobile phone signals are a form of radio waves. They're quite a short wavelength radio wave. That means they don't go around corners very well. So basically you only get a good signal when you can virtually directly see you've got a direct line of sight to a transmitter. They will go around corners a bit and they'll bounce off things a bit. So if you've got no signal at all, in the UK that probably means you're in a hole. And you can't see any transmitters. Mm-hmm. So your best bet is basically just to move around. Sometimes when you're on the very edge of getting enough reception, you can get what's called interference. So you'll get some reflections from the tower will come off one thing, and the two waves can you get a reflection and a direct transit, so the waves have gone directly towards you, or two reflections, and the two waves can either add together and make the signal stronger, or cancel each other out and make it weaker. So your best bet is your very best bet is to move higher, so you can actually see a transmitter. Your second best bet is just to move around, because you might find in some places the waves are adding together and making a stronger signal, and other places they sort of cancel each other out and make a weaker signal. So if you move around even just a few metres, sometimes you can go from somewhere where you can get good and just enough reception to no reception to just enough reception. Other than that, I don't think there's a lot you can do. I mean, really? Have you got any ideas, Dominic?
I don't think so, no. I think if you stand next to some reflective surface, you can sometimes get a better signal just because you're receiving the signal directly from the transmitter and reflected off the reflective surface.
So if you can find a place where the two signals add together.
Yes.
All right, let's have another question now. This is from Mike in Colchester. Had a lovely breakaway. Good. You're always away, Mike. Is there any definitive proof how the pyramids were built? Also, I've heard they're aligned with certain stars. Could you elaborate and tell us a little bit more about this? Definitive proof on the pyramids.
I think definitive proof when it comes to the pyramids is always going to be challenging. My general feeling is that people have always been very clever, and people in those days were at least as clever as us, if not clever. I mean, surviving when you've only got tools which are bits of rope and bits of wood and a few stones.
They had the weather, Dave.
A bit of bronze and copper.
Yeah, but they had the weather.
It was a lot more challenging. They did have the weather. And I've seen the things my dad has shifted with just a few balks of wood and some rollers, and he can on his own he can move things around, which are kind of best part of it, half a ton, third of a ton. And so if you've got lots of people who are enthusiastic about doing something and they've had lots of practice, and if you build a pyramid that big, you're going to get a lot of practice. I think you'll work out ways of doing it. I'm not sure of the exact mechanisms, but certainly with levers and ramps and rollers you can do an awful lot.
Yeah, I mean, for me, if I'm moving something, when I was moving house and everything, I just had a great big towel. I just put stuff on it and just hawk it across the floor, just slide it, because that was the easiest way to do it, and the safest way without me sort of really hurting myself, even though I've got shoulders like a builder. But there you go. All right. Well, we got the other thing was the stars. Oh, Dominic. Yeah, the stars, Dominic.
Yes. Now, I think the pyramids are quite precisely aligned north, south, east, west. And in addition, there were some narrow shafts cut through the stonework of the pyramids, and people have, I think, looked into whether those were aligned with stars, and I'm not sure whether they have actually found any conclusive results on that. However, certainly these ancient civilizations were very interested in alignments with stars and planets, and certainly in Britain, in Scotland, there were stoneworks which were aligned towards the most southerly point where the sun and moon can set. And there's a burial chamber in Ireland, I forget its name off the top of my head, which has a shaft cut through to the burial chamber where on the midsummer day at noon the sun will shine in for a few minutes just once a year. And obviously the midsummer sun was extremely important to these ancient people. So I certainly wouldn't rule out that there are astronomical alignments in the pyramids. I'm not sure anyone has conclusively.
I certainly heard a suggestion that some of these tunnels drilled through the pyramids were not particularly well aligned with any stars in the sky at the moment. But 5,000 years ago they would have lined up quite well. I think at the equinox, because the stars are moving relative to each other very slowly. In a lifetime you never notice it, but over thousands of years they move around and the constellations change.
All right, OK, well, we've got a lovely caller on the phone now. We've got lovely Tony. Hello, Tony.
Hi, well, you're a lovely one, dear, not me.
Oh, no, you're too charming, Tony. Now then, what is your question for Dr. Dave and Dr. Dominic?
Well, I was very interested in listening about the moon going in the... Not the moon, but or was it a moon? Going in the opposite direction to the others.
Around Saturn?
Yeah. Is that normal? I mean, does it happen? I mean, it could hit, if they came the wrong way, they might collide with each other. I wonder if that ever happens.
Yes, there are various different ways in which moons can form around planets. It's thought that often after a planet has formed, you'll have a disk of material around that planet, and some of that material will then gradually, under the force of gravity, pull together into other bodies orbiting that primary body. It's also thought that if you have planets that collide with one another, then you might have material thrown off from the primary planet that might form into a moon. And that is how it's thought our own moon was formed. It's thought that a planet called Theia crashed into the proto-Earth and threw off a huge amount of mantle. And that mantle then reformed together to form the moon that we have. The other mechanism is just that you can have asteroids which are floating through space and they wander into a planet and are somehow captured into orbit around that planet. And it's thought that's how Mars's two moons, Phobos and Deimos, were formed. So if you have a moon system where several moons have been formed by different mechanisms, perhaps some of them were formed along with the planet and others have been captured asteroids later on, they could have different orbital directions.
And if it's being captured, it could get captured one way round or the other way round. It depends exactly how it was travelling and how it got captured.
It's entirely random, yes.
Wow. Tony, has that answered your question?
I think it has.
Tony, you're a star. We love you. Thank you so much.
Bye for now.
Bye-bye, sweetie. Now, from last week in Ipswich, Jeff sent me an email, which we ran out of time, and he says, hi, Sue, could the doctors please tell me at what rate do batteries run down when a transistor radio is played on full volume as opposed to normal volume? That's from Jeff in Ipswich.
That's a very good question. It will depend on all sorts of things, not least on the design of your radio. So a modern radio, the actual decoding will be a lot more efficient than an old one, unless, of course, it's a digital radio, which the actual decoding circuitry on that is very complicated. It's essentially running a small computer, which is doing all sorts of complicated things to decode the information for you, and that uses lots and lots of power. Of course, the other thing is how loud full volume is. If you've got a tiny little radio which doesn't get very loud, then it's not going to be using very much power. Every time you increase the volume by 10 decibels, it's hard really to get an idea of what that is, but that increases the power you need in the sound by a factor of 10. And every time you go up a decibel, that feels like it goes up the same volume to your ears. So if you turn the volume up, especially near the top of the scale, that's going to use a lot more power. I think with a modern sort of small FM radio or small AM radio, most of the energy is probably being used in the speakers, definitely on a big amplifier, on a big sort of system, sort of hi-fi system. If you're wandering around with a digital radio and earphones, then most of the energy is probably being used in decoding the signal. So I'm afraid I can't really answer it any more than it depends.
It depends, right, OK. Well, it depends then. Thank you very much. I could have said that. If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Now, Johnny Peterborough says he was watching an American movie, and in this movie there was a scene where the sun was in the background, and you could actually see the flames of the sun. The question is, can you actually see this on Earth, or was it just a movie effect?
Only, I think, during a total solar eclipse. The sun does have this outer layer called its corona, which extends out several times the normal visible radius of the sun. And it does have these flame-like structures called solar flares, which are continually bubbling off the surface of the sun. But normally those are comparatively faint compared to the main disk of the sun, and hence you can't actually see them when you just look at the sun, because your eyes are just seeing the glare of the main disk of the sun. But of course, when the moon is in the way during a total solar eclipse, your eyes are protected from that glare of the main disk of the sun. You can see the outskirts of the sun, you can see these flame-like structures coming out from its surface. So unless the film was being set during a total solar eclipse, probably not.
Yeah, I think it was probably a special effect.
All right. Let's see if you know this one. Jay says, Sue, could the doc please explain what's dark matter and how do we know it's present? Good question. Dark matter.
That's a very difficult question, that is. Essentially, about 70 years ago, people were looking at the rotation of various objects in space, galaxies in particular. And they were finding that they were rotating much more quickly than they could explain from the gravitational forces holding that galaxy together. You can look at all the stars in the galaxy and work out roughly how much mass you think is there, and you can work out how much gravity all of those stars produce. And you find the galaxy is rotating so fast that it would just all fly off into space by the centrifugal force. So they think there must be some extra mass in that galaxy binding it together and stopping it from flying apart. And that is what got called dark matter. It's a fairly unimaginative name. It's just saying there's some matter there which is dark and we can't see it.
That's sciences for you, though, isn't it? I would just call it dark matter. Go on, yeah.
And additionally, in the last few years, people have been looking at objects called gravitational lenses, which are objects which bend the light that travels past them. Essentially, if you have a spacecraft that travels past a planet, its path will be deflected by the gravity of that planet. And the same is true if light travels past a very massive galaxy, its path will be bent. And if you can measure how much that light ray is being bent by the galaxy, you can estimate how much that galaxy weighs. And you find that the estimates are about 10 times what you'd imagine the galaxy is actually weighed. And hence from that you can infer that about 90% of the mass in that galaxy must be something that we're not seeing, and so dark matter. And so the short answer is we don't really know what dark matter is, we just know it must be there.
We just made it up.
Holding things together.
Or it might be that gravity doesn't work the way we think it is, I suppose.
Some people have been doing some research into that, wondering if there's a new theory of gravity. But I'm not convinced they've made... I mean, they have shown that such theories can exist, but I think it's quite difficult to prove such a theory.
All right, more questions here. We've explained about dark matter, at least we think we have. How near are we to using light for propulsion?
Well, I guess it is sort of ultimate propulsion. In some ways, it's the ultimate form of propulsion. All kind of sort of space rockets work in the same way. You throw something one way. And because Newton's one of Newton's laws says every action has an equal opposite reaction, that basically means if you push something, it pushes you back. So if the rocket throws something one way, pushes it one way, then the stuff it's pushed is going to push the rocket the other way. So normal rocket, so you can do this with a water rocket and throw water downwards and the rocket goes upwards. And the faster you throw it, the more push you get for every kilo of stuff you throw out. So if you throw water out of a water rocket, you don't get very much push per kilo of water. So if you tried to make a water rocket go into space, it would have to be absolutely immense because you don't get very much lift for each kilo of fuel, and then you've got to lift more fuel to get it even higher, and you've got to lift, then all that fuel's got to need even more rocket to lift it. It gets ridiculous. So normal space rockets throw really hot gases out the other way, going really quite fast, sort of thousands of miles an hour out the bottom. And that means that the rocket gets much more push for every kilo of fuel, so it can go a lot further. If you want to go even further, but that kind of limits you to getting around the solar system. If you want to get people to Mars, it'd be very, very difficult, actually, with a normal chemical rocket. So you want to push stuff out even faster to get more bang for every kilo of fuel you've got. So people use what are called ion engines, whereby you basically knock the electrons off some of your fuel and heat it up, make it very, very hot, then throw it out the back of your rocket using basically electrical propulsion. You can either do it by just heating it electrically, or you can use it by accelerating it using electric fields. And that can throw things out much, much faster. The rockets at the moment don't produce very much force. They do produce a lot of force for every kilo of propellant, and that's really important once you start going a long way. And so they've actually just been testing one which they think, if they scale it up a bit, could get people to Mars in about a month rather than in 6 months, which would be a lot better for things like radiation, which is really bad on long space journeys. And the ultimate one is light, because light is essentially is moving it's the fastest moving thing of anything in the universe. So you get the most force for every kilo of fuel. But the problem is, as you throw things out faster, you also need more energy for every kilo of fuel. And so it becomes less and less efficient energetically. So in some ways, the ultimate rocket would be throwing light out the back of your spaceship. But it would need an absolutely immense amount of energy, and we're nowhere near needing that, let alone building something which would use it.
So it's not going to be happening.
It's not happening anytime soon.
Let's go to our next question. Dr. Dave and Dr. Dominic. Steve is asking, why don't creatures die that store venom?
That's a very good question. The biggest thing, in fact, we've got various poisons in us, in various digestive enzymes which we use to digest food, are actually really quite poisonous, and if they got into our blood, it would kill us really quite quickly. And particularly all the fluids in our stomach. I mean, that's incredibly strong acid. If that gets out of your stomach, it can cause complete havoc. So the first thing which poisonous creatures do is by locking it up inside a bag, and the bag is kind of poison-proof, essentially, waterproof, and so the poisons can't get out. So all the poison is locked inside our digestive system. In a snake, it's all locked inside its venom glands around its teeth. So it doesn't actually get out, and it can't actually do any damage to the snake. Some snakes also have antibodies to their own venom. So if they do accidentally bite themselves a bit and you do get some venom inside their bloodstream, it will cause them some problems, but it can sort of get mopped up a bit by these antibodies. But basically, it's all about keeping the poison away from anything vital.
Ooh. Hello to Bob in Essex, who says, why is it when we look at a rainbow we only see an arc? Is it possible to ever see a rainbow as a full circle? Oh, how romantic, Bob.
The simple answer is yes, but you need quite specific circumstances. Basically, with a rainbow, it's created when light comes from the sun or any other white light source. It hits raindrops, and then it gets split up into lots of different colours. And it comes out of the raindrops, and so in such a way as if you look at raindrops in different directions, you see different colours. Basically, you end up with a rings of different colours at about 42 degrees away from the line exactly opposite of the sun. So wherever you are, it's always 42 degrees away from the line opposite the sun. That means that if you're standing on the ground, you can never see a circular rainbow, because the only way you'd be able to see a circular rainbow on the ground is if the sun was under your feet, and then the earth gets in the way. Because it's always going to hit the ground. The only way you can see it is by being up in the air. You can sometimes see it if you're up in a mountain and you're looking down, and the sun is behind you, and there's enough sort of clouds and rain below you to be able to see the rainbow down below you. And the other classic place is in a plane, because in the plane there's lots of atmosphere below you, lots of space for rain to be below you, and so you can actually see the full circular rainbow.
Looking at one here from John, he says, Dr. Dave, when they introduced the modern calendar, e.g. BC AD, how and when did they know that Jesus was going to be that significant? Ooh, good question.
It's a very good question. The modern calendar was certainly invented a long time after Jesus. I don't know exactly when.
It was in the time of Pope Gregory, hence it's called the Gregorian calendar, and that was around about 1600-ish, I think. Before that, you had the Julian calendar, which had been running since about Roman times. Which was gradually getting out of sync with the seasons, because in that calendar the year is exactly 365 and a quarter days long, and of course the year is actually 365.2524 etc. days long, and so people started to notice that the seasons were drifting slightly with respect to what was actually being observed in the sky, and this was a particular problem for the Christian Church, because Easter is set relative to the spring solstice, spring equinox, and that meant that they couldn't decide when Easter was going to be, and of course for the Catholic Church this was a huge headache, and so they decided that they would reform the calendar to make sure that the equinox fell when it was supposed to fall, and hence they put it back to the date that it had been in about 400 AD, when the rules for working out when Easter was supposed to be were set. So the simple answer to the question is that the AD-BC system is a relatively new invention.
All right, Jerry in Bury St Edmunds sent an email in. Hi, Jerry. Nice that you're listening to the show. He says, what existed before the Big Bang?
Gosh. There is, I guess, a question as to whether that is a scientific question that you can ask, because all of our scientific experience of our surroundings comes from observations of what's in the universe. We can't see anything which is outside the universe. And so, in a sense, you can speculate as much as you like, but if you'll never see it, then you can't really test those scientific theories. Now, certain cosmological theories do make predictions about whether there are things outside the universe before the Big Bang, or whether there were multiple universes, so-called multiverses. And I know that Sir Martin Rees is certainly quite keen on one cosmological theory called the multiverse theory, where there are several universes. I think those cause quite a lot of philosophical problems because they are, as I say, untestable. There are no observations that you can compare them against, and so it's very hard to say whether they're right or not. So as for what there may or may not have been before the Big Bang, I think you're into the realm of speculation there.
And certainly if the Big Bang occurred the way people think it did, and it was incredible, and the universe was that dense and that hot, we're not really sure that the physics we know about works in those kind of extreme conditions, in the same way as Newton's laws that work beautifully on Earth, and there's virtually everything which you do with like snooker balls and things the size of people with Newton's laws work fine with Newton's laws. And it's only when you start going incredibly fast or get incredibly small that they start to break down, and you start needing relativity or quantum mechanics. We don't know that our ideas of quantum mechanics will work at incredibly high temperatures, incredibly high energies, which would happen just at the Big Bang. So there's no way of really guessing what happened before by looking at the universe now, because we don't know how the universe would have behaved in those situations.
I mean, you can certainly present an argument that there might be a mathematically very beautiful theory that has some particular predictions for what there was before the Big Bang. But all you're doing there is saying this is mathematically beautiful, and perhaps the universe is mathematically beautiful. If the universe chooses not to be mathematically beautiful, your theory may be wrong.
So, unless we find some good evidence about the way in looking at the universe very carefully, and it's not behaving the way we think it is, then we've got no idea.
Captain Catherine Janeway from the Starship Enterprise, she knows. Right. Dr. Dave, would it be possible for NASA to build a giant satellite that orbits the moon and for people to visit and live on for months on end? From Mike.
It's an interesting question in all sorts of ways. I guess the first question is, could you build it? There's no fundamental reason why you couldn't build a very large satellite around the moon. I think satellites around the moon are not very stable because the Earth tends to perturb their orbits. And so you might have to use lots of rocket fuel to keep it in orbit around the moon for a long time. The other thing is whether people could live on it for months on end. And there's a big problem with radiation in space. On Earth, we're protected from the radiation both we've got lots of atmosphere above our heads, and also the Earth's magnetic field tends to trap charged particles which are coming from both from the sun and from outside the solar system. Incredibly high energy, basically radiation. They get trapped by the magnetic field and they pile into the north and south poles, creating the northern and southern lights. If you're in space, you've got no shielding, really. And while most of the time you can get away with being out in deep space for a few weeks or a few months, it just increases your chances of cancer occasionally. If you get hit by a major solar storm, the levels of radiation can get absolutely immense and so high that it can kill people in a matter of hours or minutes. And there were several solar storms in around the Apollo missions, and if one of them had actually happened to coincide with one of the missions, then the astronauts would have been killed just by the radiation. And so if you're staying up there for months, it starts to get dangerous that you might get hit by one of these. So not without a lot of improvements in shielding technology could people live out in deep space for a long time.
Well, they're space travelling already, aren't they? Would you like to go up, Dominic?
I think as a kid I was quite keen. Yeah. I think now maybe that I've heard a bit more about G-forces that you have to go through to get up there, maybe.
Yeah, don't do that, it's dangerous.
Maybe I'll leave it to other people.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.